Your project is running late, your mounting system just got 20% more expensive and you have no idea why. The answer isn't in your project site. It is in the oil field 3000 kilometers away. If you work in solar as an EPC, a developer and a manufacturer or a policy advisor, the next few minutes will change how you think about your supply chain. Stay with me. Why solar professionals must care? Most solar professionals believe they operate in a clean energy world insulated from fossil fuels volatility. That belief is costing them crores. Global oil prices have been volatile since 2021, driven by Russia-Ukraine conflict, OPEC production cuts, refinery constraints, and post-COVID demand recovery. LPG gas has been under particular pressure due to supply disruptions and surging demand in Asia. Solar PV panels have been cheaper, but the mounting structure, the steel and aluminum skeleton that holds those panels for 25 years is deeply embedded in fossil fuel economics. The steel is made in LPG-powered furnaces. The zinc for galvanizing comes from energy-intensive smelting. The coatings on your aluminum extrusion use petrochemical chemistry. Transport runs on diesel. Every single input is a fossil fuel derivative. When oil and LPG prices move, your mounting system costs move with them. Steel, aluminum, and the raw materials squeeze. Steel forms the backbone of ground-mounted solar, your torque tubes, hat purlin sections, pile foundations, and module frames. Blast furnace operations consume enormous quantities of coke and gas. Even electric arc furnaces draw heavily from gas-fired power. Oil prices have pronounced volatility across 2022 to 24, translating to 12 to 25% swing in input cost within a single procurement cycles. Hot dip galvanizing and zinc. Here's something almost nobody talks about: the protective coating on your steel. Hot dip galvanizing uses zinc, and zinc smelting is one of the most energy-intensive processes in existence. Smelters in Europe and Asia curtailed to shut down production when energy prices made operations uneconomic. Even when steel was available, galvanized steel was constrained. The cost of hot dip galvanizing per ton has risen 18 to 25% in many markets compared to pre-crisis levels. Aluminium extrusions. For rooftop and commercial systems, aluminium is the primary material. Aluminium smelting consumes roughly 15 megawatt-hour per ton, the most electricity-intensive major industrial process. When European electricity prices surged, primary smelters shut down to cut production dramatically. Aluminium extrusion prices in many markets hit 25 to 40% above their 2020 baseline at peak. Even with partial correction, the floor has permanently shifted. The era of 150 to 160 per kg aluminum extrusion is structurally over many product grades. Price volatility, logistics, and project time risk. The procurement trap. The utility scale projects has development cycle of 18 to 36 months. The EPC contract is typically fixed price. Material procurement happens 4 to 8 months before installation. The gap between when you fix your price and when you actually buy is your exposure window. I have seen projects where mounting cost estimates at bid were 2.8 crores per megawatt and actually procurement came in at 3.6 crores per megawatt. That 80 lakhs per megawatt delta was absorbed entirely by EPC. On a 50 megawatt project, that's 40 crores of unplanned costs. Freight and LED times. Containers freight from Chinese and Southeast Asian ports hit $18,000 to $10,000 per container at peak versus $1,200 per pandemic. Inland diesel freight in India has risen 20 to 35% from 2020 baselines. On a 10 megawatt ground mount required 600 to 800 tons of steel. This is not a rounding error. It is a crore level cost line, and the lead times have stretched from the standard 4 to 6 weeks to a 10 to 14 weeks. For an EPC with a commissioning deadline tied to a PPA or subsidy window, this isn't just a cost race. it can cause the entire project. Now let's talk about India, their vulnerabilities, opportunity and policy. India has the world's most ambitious renewable program, 500 gigawatts by 2030, but its mounting system supply chain has significant structural vulnerabilities. Despite making in India momentum, domestic aluminum extrusion capacity for solar grade profiles remains insufficient. India continues importing predominantly from China, Vietnam, and Malaysia. A weak rupee compounds this. Currency depreciation alone has added 10 to 12% to import cost independent of global price movements. But there is a genuine counterpoint. Supply chain stress is accelerating domestic manufacturing in ways policy alone never could. Manufacturers in Gujarat and Rajasthan are commissioning automated roll forming lines and in-house hot dip galvanizing lines. Captive galvanizing that eliminates the margin, lead time, and quality uncertainty of outsourced work. On policy, PLI schemes are catalyzing upstream investment with increasing discussions around extending benefits to mounting structures. The ALMM framework is being watched closely, and PM Surya Ghar Muft Bijli Yojana, targeting 10 million rooftop installations, implying roughly 30 gigawatts of rooftop capacity, represents a massive near-term demand shock that domestic supply is already stretching to meet global trends. China, Europe, and the US. China remains the dominant supplier of aluminum extrusions and mounting components. But rising domestic energy costs, a geopolitical pressure, tariff escalations, anti-dumping risks, BIS certification requirements are reshaping the calculus. Smart EPCs are treating Chinese sourcing as a second option while building domestic primary relationships. Europe was the canary in the coal mine. Aluminium smelters shut down. Mounting manufacturers faced the perfect storm of high material, energy, and logistics costs. In the US, the Inflation Reduction Act's domestic content bonus is incentivizing American manufacturing of structural components, pushing mounting system design towards material efficiency and reduced fabrication complexity. What you must do now? Everything you have covered points to one conclusion: the professional who adapt will outperform those who don't. Here are 5 specific actions. First, restructure your procurement contracts. Fixed price mounting procurement in a volatile market means you are bearing all the risk. Introduce price escalation clauses tied to published indices. LME aluminium, HRC steel, zinc spot. This is standard in global infrastructure. It is underused in Indian solar. Make it standard in every contract you sign. Second, build a multi-vendor supply chain. Pre-qualified 3 vendors for every key category: structural steel fabrication, aluminum extrusions, galvanizing. Distribute volume intentionally. When one vendor hits a crunch, you have an operational backup, not a crisis. Third, optimize your material specifications. Higher strength steel grades like S355 versus standard IS 2062. E250 allow thinner sections with 12 to 18% less tonnage for the same structural performance. Fourth, build supply chain intelligence as a core competency. Someone on your team or specialist advisor needs to watch LME prices, monitor logistics indices, and track energy costs in manufacturing clusters. The EPC that gets material prices right wins bid. The one that gets them wrong loses money. This is table stakes now. 5. Scenario plan every project bid. Run 3 cases: pace, down, and stress. If your project only works in the base case, reprice the bid. If this analysis was useful, subscribe. We publish deep dive content on solar mounting systems, supply chains, and energy market dynamics every week. Content you won't find anywhere else at this level of specifications. Drop your biggest mounting system supply chain challenge in the comments. I read every comment and build future videos around what this community needs.